Hello students, in earlier lecture we have seen example of the double integration with the constant limit. Now in this lecture we see some more example of the double integration with the constant limit. So write down the example number 4th. So example number 4th is say that find integration -1 to 1 integration 0 to pi by 2. Our function is x into sin y minus y into e raised to x dy dx. So as we know method how to find the double integration of the constant limit. We can do integration of our function first of all with respect to y, and after that we can do with respect to x, or we can also first of all doing with respect to x and after that we will doing with respect to y. So as our choice, but in this example we doing as it is, means here first of all doing integration of our function with respect to y and after that we doing with respect to x. So let's see solution. Integration -1 to 1 integration 0 to pi by 2. We have given function f of x y is x into sin y minus y into e raised to x dy dx. So here first of all doing with respect to y. So we write the limit of the x out of the bracket integration -1 to 1. In a bracket we write the limit of the y integration 0 to pi by 2 x into sin y minus y into e raised to x dy dx. હવે મિત્રો આપણે જાણીએ છીએ એ પ્રમાણે આપણે ઇન્ટિગ્રેશન ફંક્શન વિથ રિસ્પેક્ટ ટુ y કરીએ છીએ ત્યારે x ના ફંક્શન કેવા કાઉન્ટ થશે? કોન્સ્ટન્ટ કાઉન્ટ થશે. ધેટ મીન્સ x and e raised to x count as the constant. Let's doing the integration -1 to 1. મિત્રો આપણે ઇન્ટિગ્રેશન જે ફંક્શન છે એનું રિસ્પેક્ટ ટુ y કરવાનું રહેશે. તો x આપણા કાઉન્ટ થશે કોન્સ્ટન્ટ, તો x એ એઝ ઇટ ઇઝ રહેશે. sin y નું ઇન્ટિગ્રેશન થશે -cos y માઇનસ y નું ઇન્ટિગ્રેશન થશે y² by 2 e raised to x as it is. Here we apply the limit 0 to pi by 2. Now first of all we apply the upper limit pi by 2 at a place of y. So let's put the limit integration -1 to 1. So first of all here we put the upper limit pi by 2 at a place of y. So minus x cos pi by 2 minus, મિત્રો y ની જગ્યાએ આપણે pi by 2 સબસ્ટિટ્યુટ કરવાના છે, તો અહીંયા y² છે. ધેટ મીન્સ શું થશે? પાઈ અપોન 2 નો સ્ક્વેર થશે. સો π² અપોન 4 અને ઓલરેડી મિત્રો છેદમાં 2 છે તો થઈ જશે π² by 8 into e raised to x. So this is the upper limit minus we substitute the lower limit. હવે મિત્રો આપણી lower limit છે 0. So x into here is the minus x cos 0. Here we substitute the y is equal to 0. So minus x cos 0 minus, મિત્રો y ની જગ્યાએ 0 મૂકી તો આખી ટર્મ થઈ જશે 0. So minus 0 into dx. Now we just give simplification of this. So integration -1 to 1 remaining, as we know value of the cos pi by 2 is the 0. So first term is the 0 minus π² by 8 e raised to x. મિત્રો અહીં cos 0 ની વેલ્યુ થશે 1. So minus x into minus થઈ જશે પ્લસ cos 0 is the 1 and last term is the already 0 into dx. So integration -1 to 1 we have just remain the function x minus π² upon it e raised to x. So our function is x minus π² by 8 into e raised to x dx. મિત્રો આપણે જે પોઝિટિવ ટર્મ છે x એને પહેલાં લખેલી છે અને -π² upon 8 e raised to x લખેલી છે. So just remain the function x minus π² upon 8 e raised to x dx. So this is the single integration. Now we are doing integration of this function with respect to x and we can easily do this. So integration of x is the x² by 2 minus π² upon 8 constant as it is And as we know, integration of e raised to x is the e raised to x. Now we'll apply the limit integration minus 1 to 1. So first of all, here we apply the upper limit. Upper limit is the 1. So 1 square is the 1. So first term is the 1 by 2 minus pi square by 8 as it is. મિત્રો x ની જગ્યાએ 1 સબસ્ટિટ્યુટ કરવાના છે તો થશે e raised to 1. So there is the upper limit. Now minus we apply the lower limit at a place of x. મિત્રો minus 1 નો સ્ક્વેર થઈ જશે plus 1. So term is the 1 by 2 minus pi square by 8 e raised to minus 1. Now we just give simplification of this. 1 by 2 minus pi square upon 8 e raised to 1 is the minus 1 upon 2. So this term becomes the minus minus plus pi square by 8 e raised to minus 1. So plus 1 half minus 1 half cut. So we have just remain two terms. So in these two terms we take pi square upon 8 is the common, take outside. So pi square by 8 take outside. So e raised to minus 1 is the positive and e is the negative. So first we write the positive term e raised to minus 1 minus a. So this is the answer, or we can also write as the pi square upon 8. મિત્રો e raised to minus 1 લખાશે 1 upon e minus a. So this is the solution of the example number 4th. So it's a very easy. Let us recall one more times. Here we are doing integration of our function first of all with respect to y. So at that time x and e raised to x count as the constant. તો મિત્રો x as it is રહેશે cos sin y નું integration થશે minus cos y. y નું integration થશે y square by 2 and we just apply its limit 0 to pi by 2. So when we apply the limit, so value of cos pi by 2 is the 0 as we know. So first term is the 0 minus pi square upon 8 e raised to x as it is minus મિત્રો લોઅર લિમિટ છે 0 એપ્લાય કરી તો વેલ્યુ થશે માઇનસ એક્સ ઇન્ટુ કોસ 0 અને વાય સ્ક્વેર અપોન 2 મીન્સ વી એપ્લાય 0, દેટ મીન્સ ધીસ ટર્મ બીકમ ધી 0. So this term is the 0 minus pi square upon 8 e raised to x minus minus plus value of the cos 0 is the 1. So just remain the plus x and this term is the already 0. So final we have remain the function is x minus pi square upon 8 e raised to x and we just doing is integration with respect to x. So integration of x is the x square by 2 minus pi square upon 8 is the constant as it is and integration of e raised to x is the e raised to x as we know and we just apply the limit and we given the simplification. So as you know, this pi square upon 8 1 upon e minus e gives the volume under the curve, our curve x sin y minus y into e raised to x and bounded by this region. તો આ મિત્રો જે લિમિટ આપેલી છે આપણો જે બાઉન્ડેડ રિજિયન હશે એની લિમિટ હશે. તો જે આપણે જોયું એ પ્રમાણે જે આ કર્વ્સ હશે આપણો એ આ ઉપરનું ફંક્શન હશે એ કોણ હશે આપણું ફંક્શન f of xy અને જે નીચે હશે એ કોણ હશે આપણી સરફેસ હશે xy પ્લેનમાં. એ કેવી રીતે બાઉન્ડેડ થઈ હશે? આ લિમિટ વડે બાઉન્ડેડ થઈ હશે -1 to 1 and 0 to pi by 2. So this integration gives the volume under the curve x sin y minus y raised to x and bounded by the region integration -1 to 1 and 0 to pi by 2. So this is the solution of example number 4. Now we see next one, example number 5th. Now our next example is double integration region R x square plus 2y dx dy where region bounded by So in example number 5, we have a given function x square plus 2y and our region bounded by limit is 0 to 1 and 0 to 2. So So sometime we have not a given limit of the function directly but given in this form. તો મિત્રો જ્યારે તમને ઇન્ટિગ્રેશન લિમિટ આ પ્રમાણે આપેલી હોય ત્યારે યુઝ્યુઅલી જે ફર્સ્ટ લિમિટ હોય છે એ ફર્સ્ટ ઇન્ટિગ્રેશનની કન્સિડર કરવામાં આવે છે અને સેકન્ડ લિમિટ હોય છે એ સેકન્ડ ઇન્ટિગ્રેશનની કન્સિડર કરવામાં આવે છે. તો મિત્રો આપણું ઇન્ટિગ્રેશન થશે integration 0 to 1 integration 0 to 2. Our function is the x square plus 2y dx dy. So let's see solution of the fifth one. So here we write as double integration r x square plus 2y dx dy is equal to મિત્રો જે 0 to 1 છે એ ફર્સ્ટ ઇન્ટિગ્રેશન લિમિટ થશે integration 0 to 1 and second limit 0 to 2 is the limit of the second integration and our function is x square plus 2y dx dy. So as we know we can do integration with respect to x or with respect to y as your choice. So here we are doing as it is integration 0 to 1 in a bracket integration 0 to 2 x square plus 2y dx dy. મિત્રો અહીં આપણે ફંક્શનનું ઇન્ટિગ્રેશન વિથ રિસ્પેક્ટ ટુ એક્સ કરી જઈએ. સો ઇન્ટિગ્રેશન 0 to 1. Now we are doing integration with respect to x. So y count as the constant. So integration of the x square is the x cube by 3 plus મિત્રો 2y constant છે તો એજ ઇટ રહેશે અને 1 નું ઇન્ટિગ્રેશન થશે x. So integration of function x square plus 2y is x cube by 3 plus 2yx and its limit is 0 to 2. Now just apply the limit and give simplification, you get the answer. Integration 0 to 1. So first of all here we apply the upper limit. Our upper limit is the 2. So મિત્રો આપણે x ની જગ્યાએ 2 મૂકી તો x cube means 2 cube is the 8. So 8 by 3 plus x ની જગ્યાએ મિત્રો આપણે 2 મૂકવાના છે તો 2y into 2 થઈ જશે 4y. So this is the upper limit. માઇનસ હવે આપણી લોઅર લિમિટ છે 0. સો એક્સની જગ્યાએ 0 મૂકી દઉં થઈ જશે 0 પ્લસ 2yx મીન્સ 2y0. સો અગેન ઇઝ ધી 0. તો મિત્રો આખી આખી જે આપણી લોઅર લિમિટ છે કેવી થઈ જશે 0 થઈ જશે ઇન્ટુ dy. નાઉ જસ્ટ ગીવ સિમ્પ્લિફિકેશન ઇન્ટિગ્રેશન 0 to 1 we have just remain the function is 8 by 3 plus 4y. So it's a very integration we can do. So now we are doing integration of function with respect to y. So 8 by 3 constant it is into y plus 4y y નો થશે મિત્રો y square by 2 and limit is 0 to 1. So now we substitute the limit. First of all we apply the upper limit 1. So 8 by 3 into 1 is the 1 8 by 3 plus 4 into 1 square is the 1 upon 2. So this is the upper limit minus our lower limit is the 0. So 8 by 3 into 0 0 plus 4 by 2 into 0 square is the 0. So this term also is 0. Now just simplify 8 by 3 plus 4 by 2 is nothing but the 2. So now take LCM. 8 plus 3 to just 6 upon 3. So 8 plus 6 14 upon 3. So 14 upon 3 is the answer of example number 5th. So 14 upon 3 gives the area under the curve x square plus 2y and our region bounded by the constant limit integration 0 to 1 and 0 to 2. So this is the solution of example number 5th. Note down the example number 6. In example number 6 we have given find double integration r dx dy. Our function is the 1 upon x plus y plus 1 whole square where our region bounded by limit is 0 to 1 0 to 1. So here both the limit are the same. So let's see solution. Double integration r dx dy upon x plus y plus 1 whole square can be written as the integration 0 to 1 integration 0 to 1 dx dy upon x plus y plus 1 square. So as we know we can do with respect to x or we can do with respect to y as your choice. So here we are doing integration of this function first of all with respect to x, or you can also doing with respect to y. So integration 0 to 1 in a bracket integration 0 to 1 dx upon our function is the x plus y plus 1 whole square into dy. अब मित्रों जो આપણું ફંક્શન છે x પ્લસ વાય પ્લસ 1 એને મેં આ રીતે લખેલ છે x પ્લસ વાય પ્લસ 1. હવે અહીં આપણું જે ફંક્શન છે એનું ઇન્ટિગ્રેશન રિસ્પેક્ટ ટુ x કરી છે ત્યારે y પ્લસ 1 કેવો કાઉન્ટ થશે? કોન્સ્ટન્ટ કાઉન્ટ થશે. જો તમે રિસ્પેક્ટ ટુ y કરવા માંગતા હોય તો તમારે લખવાનું રહેશે y પ્લસ x પ્લસ 1, તો એમાં x પ્લસ 1 તમારા કોન્સ્ટન્ટ કાઉન્ટ થશે. સો નાવ વી આર ડુઇંગ ધ ઇન્ટિગ્રેશન ઓફ ધીસ 1 અપોન x પ્લસ y પ્લસ 1 હોલ સ્ક્વેર. મિત્રો આ x આપણા વેરિયેબલ છે ને y પ્લસ 1 આખા આપણા કોન્સ્ટન્ટ કાઉન્ટ થશે. સો to understand the integration of this function, here we write as the integration of 1 upon x plus 1 whole square dx. મિત્રો આનું ઇન્ટિગ્રેશન સમજવા માટે આપણે એક એક્ઝામ્પલ જો ઇન્ટિગ્રેશન 1 upon x plus 1 whole square dx. મિત્રો 1 આપણા એક કોન્સ્ટન્ટ છે તો એ જ પ્રમાણે આપણા કોન્સ્ટન્ટ થશે y plus 1. સો વોટ ઇઝ ધ ઇન્ટિગ્રેશન ઓફ ધીસ? ઇન્ટિગ્રેશન ઓફ ધીસ ઇઝ નથિંગ બટ ધી, સો 1 upon x plus 1 whole square can be written as the x plus 1 raised to minus 2 dx. So integration of this is the x plus 1 raised to minus 2 plus 1 upon minus 2 plus 1. અને મિત્રો બાજુમાં આવશે જે કાંઈ ધાર્યું છે એનું ડેરિવેટિવ, તો x નું ડેરિવેટિવ થઈ જશે 1. સો ઇન શોર્ટ ઇન્ટિગ્રેશન ઓફ 1 upon x plus 1 whole square is nothing but the x plus 1 raised to minus 2 plus 1. Here we apply our formula x raised to n dx is x raised to n plus 1 upon n plus 1. Same way here we doing x plus 1 raised to minus 2 is the x plus 1 minus 2 plus 1 upon minus 2 plus 1. So answer is x plus 1 raised to minus 1 upon minus 1. So final answer is the minus x plus 1 inversion લખાશે મિત્રો minus 1 upon x plus 1. So integration of 1 upon x plus 1 whole square dx is nothing but the minus 1 upon x plus 1 minus 1 upon x plus 1. So here our integration of this 1 upon x plus y plus 1 whole square is nothing but the minus 1 upon x plus 1. આપણા ફંક્શનમાં છે y plus 1. So 1 upon minus 1 upon x plus y plus 1. So here we apply this formula in our examples. So integration 0 to 1. Integration of this 1 upon x plus y plus 1 whole square is nothing but the minus શું થશે મિત્રો 1 upon x plus 1 whole square હોય તો ઇન્ટિગ્રેશન થશે minus 1 upon x plus 1. So 1 upon x plus y plus 1 whole square integration is minus 1 upon x plus y plus 1. And limit is the 0 to 1 dy. Now we just substitute the limit. So integration 0 to 1. Here we substitute the limit at a place of x. હવે મિત્રો આપણે જે ઇન્ટિગ્રેશન કરેલ છે વિથ રિસ્પેક્ટ ટુ x કરેલ છે તો આપણે લિમિટ સબસ્ટિટ્યુટ કઈ જગ્યાએ કરશું? x ની જગ્યાએ. સો our first term is the minus 1 upon substitute x is equal to 1. So 1 plus y plus 1 is nothing but the y plus 2. So this is the upper limit minus 1 upon we apply the lower limit at a place of x. તો મિત્રો x ની જગ્યાએ 0 મૂકીશું તો આપણો છેદ રહેશે 0 plus y plus 1. So becomes the y plus 1 into dy. Let us recall one more times. Here we apply the upper limit at a place of x. So our first term is the minus 1 upon x plus y plus 1 is nothing but the y plus 2. Minus we apply the lower limit minus 1 upon at a place of x substitute the 0. 0 plus y plus 1 is nothing but the y plus 1. Now just simplify this. So is equal to integration 0 to 1. Wherever remain the function is so minus 1 upon y plus 2 and this term becomes the minus minus plus. So we write the first positive terms 1 upon y plus 1 minus 1 upon y plus 2 dy. મિત્રો આપણી સેકન્ડ ટર્મ પોઝિટિવ થઈ જશે અને ફર્સ્ટ ટર્મ નેગેટિવ થઈ જશે. સો વી એવર રિમેન ધી ફંક્શન 1 upon y plus 1 minus 1 upon y plus 2. So it's a very easy integration. As we know, formula of the integration of 1 upon x dx is the log x. Similarly, integration of 1 upon x plus 1 dx is nothing but the log x plus 1. So similarly, here we are doing integration of 1 upon y plus 1 is nothing but the log y plus 1, and integration of 1 upon y plus 2 is nothing but the log y plus 2. So let's doing the integration. So integration of 1 upon y plus 1 is nothing but the log y plus 1 minus integration of 1 upon y plus 2 is the log y plus 2, and we apply the limit 0 to 1. So now we first substitute the upper limit at a place of y. So log, મિત્રો આપણી upper limit છે 1, so we substitute the 1 at a place of y. So y is the 1, so 1 plus 1 is the 2, so log 2 minus log, we substitute the 1 at a place of y, so log 1 plus 2 is nothing but the log 3. So this is the upper limit, minus we substitute the lower limit at a place of y, so log 0 plus 1 is the log 1 minus log 0 plus 2 is the log 2. So here we first apply the upper limit at a place of y, so that becomes the log 1 plus 1 means log 2 minus log 1 plus 2 means log 3, minus we apply the lower limit, log 0 plus 1 is the log 1 minus log 0 plus 2 is the log 2. So now see here, log 2 minus log 3 minus log 1 and minus minus plus log 2. So this is the log 2 into log 2 plus log 2 is become the 2 times log 2 minus log 3, and value of log 1 is the 0. તો મિત્રો લોગના નિયમ પ્રમાણે જે આગળ સંખ્યા હશે ક્યાં આવી જશે, ઘાતમાં આવી જશે, મીન્સ પાવરમાં આવી જશે. તો log 2 ને લખાશે log 2 સ્ક્વેર માઇનસ log 3. So log 2 square is the 4, so log 4 minus log 3. So here we apply the rules of the log. Log a minus log b can be written as the log a upon b. So that means log 4 upon 3. So log 4 upon 3 is the answer of our integration. Here we just apply the formula log a minus log b is equal to log a upon b. So keep in your mind this formula. આ મિત્રો આપણા લોગના નિયમ પ્રમાણે જે કાંઈ સંખ્યા આગળ હશે a into log b હશે તો હું લખાશે log b raised to a. So same way here we apply the rules of the log. So 2 into log 2 can be written as the log 2 square minus log 3, and value of log 1 is the 0. So log 2 square is nothing but the log 4 minus log 3. So as a formula log a minus log b can be written as the log a upon b. So that means log 4 minus log 3 is nothing but the log 4 by 3. So answer of question number 6 is the log 4 by 3. Not need to give the simplification and to find the value of log 4 by 3. So this is your answer, not need to give more simplification. So this is the example number 4th, 5th and 6th. In next lecture we will discuss the example of the double integration with the variable limit. Thank you. Have a good day all of you.